Alright, welcome to the learning target number 10, chapter 1 video. Your learning target here is going to be, I can use the distributive property. Everybody please put a little bracket around that. You're going to learn what that is. Probably nobody knows what that is. To express a sum of two whole numbers, 1 to 100, with a common factor as a multiple of a sum of two whole numbers with no common factor. Now that learning target is the most confusing learning target of the entire year. And we, as a math department, try to figure out a better way to make that sound. But it's one of those targets where it's just easier to show you than to explain what you're really doing. But we'll get into that. But it's really focusing on the distributive property. That's what I want your focus to be. Okay, go ahead and turn in your notes to page 22.
Students had trouble with this last year, so I'll try to do a little bit better of a job explaining it. But it is difficult. Okay, so I just want you to see right now that this is kind of a difference. So it is kind of difficult. So the learning target here is I can use the distributive property, which probably most of you don't know what that property is, which is okay, to express a sum of two whole numbers, 1 to 100, with a common factor as a multiple of sum of two whole numbers, blah blah blah. I'm not even going to read it because it's hard to even understand what that's even saying. So you're gonna learn what the distributive property is, okay? And I don't want to confuse you too much on that, okay? So let me just start here, okay? If I take 5 and I do 3 plus 1. Now, you should know this from elementary school, I hope. I'm sure you guys have learned PEMDAS before. Okay, hopefully you're all nodding your head at the computer right now. PEMDAS, if you don't know, it's the order of operations in which you have to do every single math problem, okay? When you get a problem that's got operations, pluses and minuses and subtractions, or well, minuses are subtraction, it's got multiplication and division, there's an order that you have to follow. Okay, you have to do parentheses first. You have to complete the parentheses, whatever's inside of the parentheses. Then you got to do your exponent. Then you got to do multiplication or division. Then you have to do addition or subtraction. Okay, there's just an order. You can't go out of order. Okay, what I mean by that is if I gave you this problem right here, PEMDAS tells us that we got to do 3 plus 1 first. Okay, 3 plus 1 is 4, obviously, right? And then anytime you ever see a number touching a parentheses like that, that means multiply. So then you know that 5 times 4 equals 20. That's the way you would solve that problem if I gave it to you right now, or at least I hope you would. You would do the parentheses first, and then you would multiply what's on the outside. Okay? Now, let me teach you what the distributive property is. Okay? Now this property, I'll be honest, this property you're going to use it a whole lot more next year and in 8th grade. Okay, you guys will see what I mean. We figured out that the answer here was 20 by using order of operations, right? So we did 3 plus 1 and then we did times 5. We followed order of operations, okay? What the distributive property says, it says if you ever have a number on the outside, you can multiply it, just multiply it, we call it distributing. Multiply it through and then add, okay? So 5 times 3, you do that, 15, and then plus, and then 5 times 1. Okay, so I did 5 times 3, now I'm doing 5 times 1, and I'm getting 5. 15 plus 5 is 20. Okay, so you get the same answer. What I'm trying to show you is the distributive property, this is what makes the distributive property a real thing. Okay, you don't necessarily, you kind of going against the order of operations, but you can do that by multiplying it through. And that's all they did here. I just skipped that step, writing it. But you're just adding you're just adding whatever you multiplied. Okay, the same thing over here. This is 4 times 6 minus 4. So if you did it by order of operations, again, you would do it like this. You would do parentheses first. You'd get 2. And then you do 4 times 2 and you'd get 8. Okay, that's how you would have done it in 5th grade math, 4th grade math. Okay, but here we're going to do it a little bit differently. This is the distributive property way. You're going to multiply it by the terms in there. Okay, so 4 times 6 is 24. Bring down your minus. 4 times 4 is 16. What is 24 minus 16? Well, it's 8, which is what we got. So hopefully that just kind of showed you that it works, is what my goal is. Okay, so you do need to know that. Now, using GCF with the distributive property, you guys already know how to do GCF with the distributive property to create an equivalent numerical expression. Let me explain to you what an equivalent, that just means equal. Okay, equivalent means equal. Okay, and then numerical expression, obviously, we'll get to that. You guys, an expression is just like 2 plus 3. That's an expression. Okay, kind of what this kind of means is you can just, like, for instance, 2 plus 3, isn't that an equivalent to 1 plus 5? I'm sorry, not 1 plus 5. 1 plus 4 is what I was going for there. 2 plus 3 equals 1 plus 4. Those are equivalent, right? Equivalent expressions. 2 plus 3 is 5. 1 plus 4 is 5. That's kind of what this is, in a way, but it's different, okay? So, I give you two numbers, 24 and 56. I got to figure out what the GCF is. Okay, so that means you got to do all your GCF stuff here. Okay, I'm going to skip that step for now, but you would have to do that. But I already told you that the GCF was 8. You guys should be awesome at that by now. Okay, so you know how to find GCF. So you figure out that the GCF of 24 and 56, it's 8. Okay, now what you're going to do is you're going to take that GCF and you're going to stick it outside of the parentheses, just like we were doing, kind of the way it looks right there, like how that looks. Okay, so you're going to take it and you're going to put 8 on the outside of it. Okay, this A and B. The only reason that those are just variables. If you guys aren't aware, variables are just unknown numbers. We don't know what they are, but we know there's two numbers that are going to go there that are different. Okay, now what you're going to do, so you put your GCF on the outside, so it's going to be GCF and then something plus something else. We don't know what that's going to be yet. Okay, we're going to take 24 and I should have written the problem here. I didn't even write the problem. This should say, I skipped a step here. I'm sorry, guys. My notes must have gotten messed up, but this should say 24 plus 56. That's the expression, okay? What we're going to do is we're going to make a new expression, okay? So basically, we do 24, that was that number, this number right here, and we're going to divide it by 8, our GCF, and we're going to figure out what the other factor is, and we're going to do the same thing with 56, and there you go. We converted 24 plus 56. We now made it into an equivalent statement. It's the same statement, okay? Only now it's the GCF outside two factors. And I know you're confused. I would be too. So let me show you with a couple more examples, and then you guys will, I think you'll start to figure it out, because the way this is, we kind of tried to, me and the other math teachers tried to like figure it out like a step-by-step process. And this step-by-step works, but it just doesn't make sense yet. But it will. Okay, so if you're confused, you're okay. All right, now, so use the steps from the previous page to find an equivalent expression for 12 plus 18. So basically, I have 12 plus 18. I want this to be, I want to write something that's going to equal, because we know that 12 plus 18, that's 30, okay? So I want to write another thing. It's going to have a number outside of parentheses like that, and it's going to equal 30 as well. Okay. So if you think back, step 1 was to find the GCF of the two numbers here. So GCF. Okay. So we do our prime factorization over here. 12, 3 and 4, 2 and 2, 18, 2 and 9, 3 and 3. Okay. Hopefully that's like easy for you by now. Hoping. Okay. And then finally we got 2 times 3 times 3. When you're doing GCF, you only look for common factors. You do not look for, don't ever say triples, doubles, singles when you're doing GCF. That is LCM. So we look for common factors. So I see common 2s. I see common 3s. Okay. We only worry about commons. That's it. Okay. And then we use one common from each pair. Okay. So I know that the GCF here is 2 times 3, and that's going to give me 6. Okay, that's my GCF. Okay, now what I'm going to do here for step 2 is I'm going to take 6. 6, my GCF is always going to be on the outside of these numbers, or on outside of the parentheses, I'm sorry. So what I'm trying to do is I'm trying to see, okay, what would I multiply 6 by to get me to 12? Remember what I showed you with going back here? You guys don't have to flip back. I'll just show you. But remember, right here, I said we did 5 times 3 is 15. 5 times 1 is 5. That statement right there is equal to that statement. So going back here, what would I multiply 6 by to get back to 12? Well, that'd be 2. Okay, 6 times 2 would give me 12 in that spot. Okay, if you're struggling with your math facts a little bit, then you can just take your number that was given, 12, and then divide your GCF out. Okay, that's where that comes from. Same thing with 18 now. What would I multiply 6 by to get to 18? Well, it'd be 3. And thus, you've now created, we kind of skipped some steps here, but that we have done, this is the answer right here, guys. This is the answer. We created an equivalent statement. This statement right here is equal to 12 plus 18. Because the distributive property says if you multiply through here, you can do 6 times 2 is 12. 6 times 3 is 18. It's the same statement. Okay? If you want to check to see if it works, you can check. You can see that if you found the answer to this, typed into your calculator, you could type 6 parenthesis 2 plus 3 parenthesis, and you're going to get 30. And then you could just do 12 plus 18. You also get 30. But I want you guys to see, I don't want you to get confused here. This is the answer that I'm looking for. That's what I'm looking for right there. I'm looking for the GCF and then the problem on the inside of the parentheses. That gets you back to the original. Here we go. Okay, 16 and 24. Step 1 is to find the GCF. So 16 would be 2 and 8, 2 and 4, 2 and 2. And after a while, you're going to start memorizing these prime factorizations, trust me. 24 is 3 and 8. Okay, now we'll go ahead and stack these. I didn't leave you a ton of room here, but that's okay. 2 times 2 times 2 times 2. And then 24 is 2 times 2 times 2 times 3. Okay, I look for common factors. I see a common 2's. I see another set of common 2's. I see more common 2's. Okay, that's it. We don't worry about triples, doubles, singles. That's LCM. So then I use 1 from each of these. 1 from each, 1 from each. That's 2 times 2 times 2. That's 8. My GCF is 8, okay? So now I know that my GCF goes on the outside of the parentheses. Okay? And then I say, okay, what would I have to multiply here? 8 times what to get me back to 16? 2. What would I have to multiply here to get me back to 24? 3. And there's your answer. Okay? Here, 20 and 50. Okay? Now, do your prime factorization first. 20 is 2 and 10. 2 and 5. Okay? 50 will be 5 and 10. 2 and 5. Right? And I'm going fast on that because I'm assuming that you guys are really, really good at that by now. Your prime factorization for 20. Here's your prime factorization for 50. 2 times 2. Wait. Sorry, that's wrong. Can't even read my own handwriting. 2 times 5 times 5. I look for common factors. I see common 5s. I see common 2s. So that tells me that my GCF is 2 times 5, which equals 10. That's my GCF. So I know that my GCF goes on the outside of here. And I ask myself, what would I have to multiply 10 times to get me back to 20? Well, 2. And what would I have to multiply 10 by to get me back to 50? Well, it'd be 5. Okay? Hopefully you're getting the hang of it. I'd like you to try number 3 and 4 on your own. Pause it and try them. Okay. Okay, here we go. 6 plus 10. Do your prime factorization. Hopefully you've already done that. You better have already done this. Okay, and then 10 is 2 and 5. So I stack those. 2 times 3, 2 times 5. I see common 2's. That's all they have in common, so therefore the GCF is 2. The GCF goes outside the parentheses, and then I say, okay, what would I multiply 2 by to get me back to 6? 3. What would I multiply 2 times what would give me 10? 5. Okay, there's your answer right there. Let's do another one. 9 is 3 times 3. 36 would be, you could use, again, you could use 12 and 3. Let's use that one. I haven't used that one, I don't think, yet. 12 and 3, 3 is prime. 3 and 4, 3 is prime. 2 and 2, 2 is prime, okay? So 3 times 3, and then 2 times 2 times 3 times 3. Okay? I see that I have common 2's. Common 3's. I have 2 sets of common 3's. So I use one of those to bring it down. 3 times 3. My GCF is 9. Okay? So my GCF always goes outside the parentheses. 9 times what would give me 9? 9 times 1. Okay? And then 9 times what would give me 36? 9 times 4. Okay? And you can check it. Do it. Just use the distributive property. 9 times 1 would give me 9. 9 times 1 would be 9. 9 times 4 would be 36. So,
alright, if you want some additional practice, you can do these last 3 problems at the bottom of page 23. You do not have to do these bottom 3. You can shut it off now if you'd like, but if you want some extra practice, here you go. Alright, you can either pause this and try them on your own, or if you just want me to go through them, that's fine too. So, remember, the first step we're creating equivalent expressions, and the first step is we got to find the GCF of the 2 numbers. Okay, find GCF. And you guys all know the first step to GCF is to do the prime factorization. 35 would be 5 and 7, and those are both prime. 91, kind of a tricky one. Okay, now remember, it's odd, so we're going to check 3, 5, 7, and 9. Okay, check 3 by doing 9 plus 1 is 10. Okay, 3 wouldn't be a factor of 10, or 91. It doesn't end in 5 or 0. And then remember, the rule for 9 is the same as 3. 9 plus 1 is 10. 10 does not have a factor of 9. Now 7, remember, that's the one where you just got to kind of do it. There's not really a rule that's going to be useful for us. So we're going to have to just divide it, see if it gives you a whole number. So 7 goes into 9 one time, then we multiply around, then we subtract to get 2. Okay. Now we're going to bring down 1. 7 goes into 21 3 times. 7 times 3 is 21, and we do learn that this does have factors of 7 and 13. Okay, so breaking this down would be just 7 and 13 because those are both prime. Okay, that's a tough one. That's a really, really hard one. So I stack my prime factorizations. So I'm going to do 5 times 7 and 7 times 13. Right away, you're probably going to see that the GCF is going to be the only CF other than 1 that they have, and that is going to mean that the GCF equals 7. So coming up with the equivalent expression, remember the GCF goes out here, and then we just ask ourselves, what is the GCF? It's 7. Okay, what would 7 multiply by to get you back to 35? Hopefully you're all saying 5. My mouse would work. There we go, 5. And then 7 times what would get me to 91? We just did it up there. That's what we worked out, and there you go. There's your answer. Okay. Next one. Okay. Do the GCF first of all. So we got to do prime factorization. 60 is going to break down to 6 and 10. This is going to break down to 2 and 3. This is going to break down to 2 and 5. And there we go. 85, a little bit a harder one because that's one of those that isn't going to show up on our multiplication table. So I know that it ends in a 5, so I'm just going to go ahead and just break it to 5 and something. I know it ends in a 5, so therefore it has a factor of 5. So you may have to go up and do 85 divided by 5. 5 goes into 8 once, multiply around, Bring down my 5 and I get 35. 5 goes into 35 7 times, and there you go. We finally subtract and we get 0. So we know that 5 times 17 is going to give us 85. Both of those numbers are prime. So now we're ready to stack it up. So we're going to go 2 times 2 times 3 times 5. Always multiply it out to make sure. 2 times 2 is 4, times 3 is 12, times 5 would be 60, and then 5 times 17. Okay, it's an awful lot of work to determine that the only prime factor they share is 5. So there we go. Now we're ready to rock and roll. So here we go. We put that outside our parentheses. Remember, the distributive property is when you multiply the number outside the parentheses by both numbers on the inside. Okay, so 5 times what would get me back to 60? That would be 12. 5 times what would get me back to 85, and we just learned that that's 17. So there you go. That is the answer to this one here, number 13. Next one, 24 and 64. I'm going to try to save a little bit of time. You should have done your prime factorization, and you should have found that 24 would be 2 times 2 times 2 times 3. 64, 2 times 2 times 2 times 2 times 2 times 2. Okay, so you look for CFs. I see that they have 2's, they have 2's, and they have 2's. That's all they have. So I know that I use one of each of those, and I multiply them. I know that my GCF is 8. Okay, so remember, I put my GCF outside the parentheses, and then I kind of work backwards here. I say, what would I multiply 8 times that would get me back to 24? Well, that'd be 3. Okay, what would I multiply 8 times that would get me back to 64? Hopefully you all got 8. Now remember, when you get done with all these, you should always be able to go back through and multiply and get the number that you started with. So when you actually distribute, 7 times 5 is 35. 7 times 13 is 91. Is that what we originally started with? Yes, it is. Okay, same goes for this one. I know that 5 times 12 is 60. 5 times 17 is going to give me 85. Is that what I originally started with? Yes, it is. Okay, 8 times 3 is 24. 8 times 8 is 64. Is that what I originally started with? Absolutely. Okay, so hopefully that helped.